One of the most important elements of investing is risk. It represents the uncertainty that's present in nearly every financial transaction. We usually assume that investors earn a certain rate of return on their investments. However, there is always the possibility that they will earn less return than they originally expect. This is known as investment risk. Investment risk pertains to both individual stocks and portfolios of stocks. The risk of an individual stock is known as its standard deviation, which is denoted as sigma, whereas the risk of an entire portfolio is measured by beta. Also, we can predict investment risk before we earn any return, known as ex ante, or we can summarize the risk of an investment after we realize its return, known as ex post. So let's look at some ex ante statistics. The expected return will denote R hat, and this is just the sum of the weighted returns that are assumed to be in the future periods. So we're looking forward into the future. This is ex ante, so we're trying to predict the return we're going to earn. And there are several different states of nature that have a certain probability of occurring. So we might have a good period, we might have a bad period, or there could be 3 different periods or whatever. It's just that each period has a certain return associated with it, and we know something about the probability distributions of those future periods. And so what return do we expect to earn? Well, it's just the sum of each return multiplied by its probability. The variance, which is denoted sigma squared, is just the sum of all the different n states of nature, so the sum from I equals 1 to n, of the probability of the ith state of nature occurring, times the return associated with that period, minus our expected return, which was the first thing that we calculated, squared. And the reason we square is to keep everything positive. So basically you're looking at the error. You're looking at the error between what the return is in that period versus your average or expected return. The standard deviation is just the square root of the variance. And then one more thing, the coefficient of variation, sometimes denoted CV, is the standard deviation divided by the expected return. So it tells us a little bit about how much return we're earning based on the risk or the standard deviation of a stock. Let's look at some examples. The following table shows the rates of return for 2 securities, A and B, during 2 different potential states of nature. So here we see there's 2 states of nature that are going to be happening. Either we're going to have a high period or we're going to have a low period. And the chance that we think we're going to have a high period is 40%. And the chance that we think we're going to have a low period is 60%. And we see the 2 securities. Security A, if we do end up in a high period, is going to earn 15% return. And if we end up in a low period, it's going to earn 5%. Security B in a high period earns 35% return, and in a low period, it earns minus 5%. So let's calculate the expected return for security A. Remember, it's just the sum of over all the periods of the probability of each period occurring times the return in that period. So we start with the first period, the high period. It has a probability of 40% occurring, so we take 0.4 and we multiply it by the return that security A earns in the high period, which is 15%. So 0.4 times 0.15. And then we're taking the sum, so we add and we do the same thing for the low period. There's a 60% chance of it occurring, so we do the 0.6 times the return that A earns in a low period, which is 5%, 0.05. When we do that, we see that we expect to earn 9% with security A. Let's calculate the variance for security A. Remember, the variance is the sum of the probability of each state of nature occurring times the difference of the return in that period and the actual expected return squared. So first we start with the high period. It has a probability of 40% occurring, so we do 0.4 times the return in the high period, which is 15%, 0.15, and then we subtract off the expected return of 0.09, 9%, and then we square it. And we do the same thing for the low period, and we add it together. So plus the 60% chance of the low period occurring times the 5% we would earn in the low period minus the 9% expected return squared. And we see that the variance for security A is 0.0024 or 0.24%. Now we can calculate the coefficient of variation for security A. It's the standard deviation divided by the expected return. So the standard deviation is just the square root of the variance, which is 0.049, the expected return we already found is 0.099%, so we see that the coefficient of variation for security A is 0.544. Now I'll let you do these three measures for security B by yourself and make sure you understand everything, all the calculations. We can also find these statistics using our calculator, but we have to find a way to input the probabilities of the different states of nature. The easiest way to do it is to enter the number of times the state of nature occurs over some given number of periods. The number of periods should make it easy to find out how many times the particular state of nature occurs. So in the last example, we had some probabilities associated with two different periods that were occurring in the future. And if we wanted to use our calculator to find the mean, the average expected rate of return, and the standard deviation, well, we can't just put in the return that occurs in each period. We have to find out some way to incorporate the probability estimates of the future states of nature. So to do that, instead of putting in 40% and 60%, we're just going to come up with some fixed number of periods. Let's just say 10. And that will make it easy if we assume those two probabilities for the high period and low period over those 10 periods. Well, if high period occurs 40% of the time, then we'll expect to have 4 high periods. And if the low period occurs 60% of the time, over those 10 periods, we'll expect to get a low period 6 times. So we can use that information to input this into our calculator. So let's look at this example. So from the previous table again, there was a 40% chance that security A had a return of 15%, and there was a 60% chance it had a return of 5%. And again, those were based on the two probability estimates for the future state of nature and what security A earned in each of those states of nature. So let's just say there was a total of 10 periods. Well, we'd expect our return to be 15% a total of 4 times and 5% a total of 6 times. Using our calculator, we would just enter the following. We earn 15% 4 times in this hypothetical situation where we have 10 periods. So we would enter in 0.15 and then press the capital sigma plus button to tell our calculator that we're entering this information into a collection of data. And then we earn 5% 6 times, again based on those probability estimates for the future states of nature. So we enter in 0.05 and then we press the capital sigma plus button, and we do this 6 times because we're earn 5% a total of 6 periods. Now we can just press the X bar Y bar button to get our mean, which is our expected rate of return. And it's going to be 9%, the same way we found it in the first time. The standard deviation we get by pressing this button, sigma X, sigma Y, and we get the 0.049. We get the same answer as we did before. So this is just a way, if you feel more comfortable using your calculator, you can to get the correct answer by entering in the data over this hypothetical fixed amount of periods. And so now the average return, we're talking about ex post statistics now. And this is when we're looking at data that's historical, data that's already collected, that's already occurred. We've already realized these yields, and we can calculate our average rate of return over some amount of periods. And so the average return is the sum from t equals 1 to n, where each t is a time period, and we just sum up the returns and we divide by n, capital N, the total number of time periods. This is the same way that you would calculate an average for anything. It's just a standard average formula, so it'll look pretty familiar. The variance, we denote capital V to denote it from the variance when we're dealing with ex ante data, which we denote sigma squared. So the variance for ex post statistics is the sum from t equals 1 to n, again those are the time periods 1 to n, of the return in each time period, r sub t, minus the average return over all of those time periods, which is r bar sub avg, r bar average. We square that, again to keep the distances positive, and we divide by capital N minus 1. The standard deviation, which we denote little s to differentiate it from the standard deviation of ex ante data, which again we denote sigma, is just the square root of variance. So let's look at some examples. The following table shows the rates of return for two securities, A and B, over the last 4 years. So here we have year 1, year 2, year 3, and year 4, and we have security A, security B, and those numbers show what each security earned in each year. Let's do the average rate of return for security B over the last 4 years. So again, the average rate of return is the sum from t equals 1 to n of the return in each year divided by big N, the total number of years. So it's just in year 1, security B earned 23%, in year 2 it earned 8%, and then 13%, and then 12%. So we add up all those rates of returns and we divide by 4, the number of years.